Hi everyone. Today will be mainly about metabolism, citric acid cycle, also known as the Krebs cycle, and this is just going to be a brief overview of a little bit of everything. So what is metabolism? I think that can be best described as this. So metabolism. So what is that exactly? So it's going to be all the chemical reactions in our bodies. So it's going to be all chemical reactions within our body, and they energy produce energy and substance for growth. This is for growth. Okay, and we can break that down some more. So in this case, it's going to break down into catabolic reactions and anabolic. I'm going to leave some room for the catabolic. So what exactly are catabolic reactions? So they break down large complex molecules from food. So all the food you ate is going to break it down into smaller ones, and it's going to release energy that way. So it's going to mainly happen within 3 stages. So stage 1 is going to be digestion. In digestion, the molecules are going to be broke down into smaller ones, and they're going to enter the bloodstream. Stage 2 is going to be degradation. Degradation is going to break down those molecules into compounds that have either 2 or 3 carbons in them. Stage 3, which is oxidation, is really just going to break down those small molecules and oxidize them even more within the citric acid cycle and the electron transport chain. And that's going to generate that ATP energy. For anabolic reactions, this process also uses ATP energy, but this time it's gonna build all those compounds and molecules again that are generally needed for growth and repair. Now, I've mentioned this molecule a couple times. ATP. What is ATP exactly? Gonna stand for adenosine triphosphate. And this is the one molecule that is the primary energy within our body. Where the energy is stored is mainly within its phosphate bonds. So when those phosphate bonds are broken or a phosphate group is removed through hydrolysis, ATP is going to convert to ADP, which is going to be this. So ATP is just going to hydrolyze into ADP plus an organic phosphate. So pi stands for, when it's written this way, it stands for an organic phosphate. The reason we have ADP and the organic phosphate is because, remember, ATP is hydrolyzed, and when something is hydrolyzed, it breaks down. So a phosphate group is broken away from triphosphate, and tri means 3, and di means 2. So there's going to be adenosine diphosphate with 2 phosphates and just an extra phosphate group right here. And when the hydrolysis happens, it's going to generate 7.3 kcals per mole of ATP. And this thing, ADP, can be hydrolyzed again. So ADP can be hydrolyzed again into AMP, which is adenosine monophosphate, which means one phosphate, plus a pi, plus another 7.3 kcal per mole of ATP. Okay, we're gonna go more in depth with our catabolic reactions. And remember, stage 1 is digestion. Everyone knows more about digestion. More or less, it's about the process that converts large molecules to smaller ones that can be absorbed by the body. So let's start with digestion. So digestion, and first thing we're going to start off with are carbs, carbohydrates. And just right, carbs. So digestion starts in the mouth, of course, because our mouths chew up our food that we eat, and enzymes within those salivary glands that produce our saliva are going to break down the starches of carbs into smaller polysaccharides. So let's write enzymes break down starches into smaller polysaccharides. And these are just going to be polysaccharides such as maltose, and another really well-known one you guys might have heard of is glucose. And then once this happens, it's all going to go down to stomach. Where the stomach acids will basically stop where the stomach acid just basically stops the carb digestion. Where it stops carb digestion. Like that. But that's not it. Once it travels through the stomach, it's then gonna go down to small intestine, which has around a pH of 8, so it's a little bit more basic than the pH of our body, of the whole body, like in general. The pancreatic enzymes will further break down these small polysaccharides into smaller monosaccharides. So they break down polysaccharides into monosaccharides, which are later absorbed into the bloodstream. Which are later absorbed into the bloodstream. Like this. But however, this is just carbs. You have to remember there's other things that we eat, such as fats. In this case, however, the fats will start. In this case, however, the fats will start digestion in the small intestine. Within the small intestine. There will be little things called bile salts. The bile salts will break down the fats into smaller particles called micelles. Fats into small micelles. like this, micelles. These micelles are then hydrolyzed again. So micelles are hydrolyzed again into fatty acids plus glycerol. So I'm gonna try to change my writing here. Let me move this down a bit. These are reformed within the intestinal lining. And they're just going to be bound to proteins through the lymphatic system, and they'll be carried to the bloodstream within the cells, like that. Now, we can't forget about our proteins, though. In this case, it starts in the stomach. And basically, enzymes start breaking down the proteins into polypeptides. Proteins to polypeptides. Then they're going to move into the small intestine. Then in the small intestine, more enzymes will break down those polypeptides into basic amino acids. And then those amino acids get absorbed into the intestinal lining and enter bloodstream. Don't forget, this whole area is just for digestion. However, this whole area is for carbs, this is for fats, and this is proteins. I'm going to highlight it when it gets dry. So what are the main points exactly? Well, we can't forget catabolic reactions occur in 3 stages. And the 3 stages are digestion, degradation, and I'm going to try to fit it, oxidation. This tiny little thing right here. They also occur, anabolic reactions also occur. Remember, they build large molecules. And catabolic breaks down large molecules. ATP is also really important. It's going to be the main energy unit of everybody's body. Everybody uses ATP. Remember, ATP can be hydrolyzed into ADP plus a phosphate, and that can also be hydrolyzed again into AMP plus PI, and every hydrolysis equals a 7. Every hydrolysis releases 7.3 kcals per mole of ATP. This digestion is the main part of the catabolic reactions, and the main parts that are digested are carbs, fats, and proteins. Okay, clearly the highlighting didn't go well, but I've tried putting a star next to each part that I suggest is important. So this is part 1. Expect something else soon in the near future. Thanks for watching this part 1. If you like this, consider subscribing. Consider this, or liking the video. This, or both. Either one's good option. I don't specifically post chemistry videos, but I do post school videos. So if you like those and you like having your brain filled with information, then yeah, please consider subscribing. And Mr. Krabs will see you very soon.